Let's suppose that F represents a force vector and delta S represents a displacement vector. The force vector has components parallel to delta S and perpendicular to delta S. To find the component of F that's parallel to delta S, or the component of F in the direction of delta S, simply sketch a projection line from F down to delta S at a perpendicular, and this vector from here to here is going to be the component of F in the direction of delta S. Excuse me. Now, keep in mind it's possible for this force to be at an angle greater than 90 degrees with delta S, in which case the component might well be, the component in the direction of delta S might well be negative, meaning it's actually opposite the direction of delta S. Now, this component is simply one side of a triangle. This triangle has a side here that's equal to the magnitude of F. That's the hypotenuse. This is a right triangle, so that this side of the triangle is just magnitude of F times the cosine of theta. So what we're trying to do is we're trying to find the magnitude of this component, and that magnitude is just going to be magnitude of F cosine theta. Now we know that F delta S is magnitude of F times magnitude of delta S times the cosine of theta, and that contains F magnitude of F cosine theta. If we simply divide by delta S, then we're going to get just magnitude of F cosine theta. So if we imagine dividing both sides of this equation by magnitude of delta S, we'll be left with the desired quantity, magnitude of F cosine theta here, and on this side we're going to have just F dot delta S, and that's a dot product there, let's put that dot in there, divided by the magnitude of delta S. So this is going to be a way that we can easily calculate this side of the triangle. Now, this might end up being positive or negative, so we might have the negative of the length of this side. But in either case, if we multiply this by a unit vector in the direction of delta S, we're going to get this vector, the component of F in the direction of delta S. And that's going to work whether the cosine of theta is positive or negative, because this component might be in this direction or back in this direction.